Hi students, coming to the next topic, that is bus architecture. So what is a bus? A bus is nothing but it is a communication pathway connecting two or more devices. Means it's just giving a communications between the devices. So a bus that connects major components. So what are the major components in the system? The major components are processor, memory, input-output devices is called system bus. So bus is nothing but it is a way of communicating two or more devices. And coming to the system bus is nothing but the bus that connects the major components in the system like processor, memory and I/O devices is called system bus. Actually, the system bus, whatever here is, it typically contains, this system bus typically contains about 50 to 100 hundreds of separate lines, and each line assigns some function. What it means? Actually, whatever the bus you are taken, a bus consisting of set of lines. A single line you call it as a bus. Okay. So a system bus consisting of set of lines will be there. Set of bus lines will be there. So these bus lines, this set of bus lines may be 50 to 100. It's nearly 50 to 100 are present in system bus. A system bus consisting of set of bus lines, those may be around to 50 to 100. So each line, so whatever the line, each line assigns some functions, means it is having some meaning. So that is a system bus. Actually, a system bus usually separated into three functional groups. So whatever the system bus means, it's just a communication, a connector between these components, major components, processor, memory and I/O. And this system bus separated into three functional groups, means the group of lines are separated into three functional groups. System bus usually separated into three functional groups. So those are data bus, address bus and control bus. So a system bus means a set of bus lines is divided into three separate buses: data bus, address bus, control bus. Data bus is used to hold the data, whatever the data that processor has to work on, and the processor is going to be sent to memory and I/O devices. And the address bus indicates from where we have to get the data and from where we have to put the data. So that indicates the address bus. And the control bus is used to monitor the data and address. So it always monitors the system. Okay. So these are the three buses. These call it as a system bus. A system bus consisting of data bus, address bus and control bus. So let me explain this system bus with the diagram. So here I said the system bus is used to connect the major components in the computer system. What are the major components? CPU. The CPU consists of ALU, arithmetic logic unit, registers and control unit. So this is one component, CPU, memory, input output unit. Okay, so these are the three major units. So these three major units are connected with the help of system bus. So this is a system bus. A system bus is having data bus, address bus and control bus. So this system bus is connected to CPU. Okay, so this is a data bus. A data bus is a bidirectional. The data is sent from other devices to memory and from CPU to other devices, from other devices to CPU. And address bus is a unidirectional, whereas control bus is it's a bidirectional. In the same way for memory, okay, so this is a system bus that are connected to a major components. Let us discuss one by one. So first is data bus. So what is the use of the data bus in the system? So a data bus is nothing but it is used to carries data. It carries data from one device to another device. So it consists of 8, 32, 64, 128 or even so on, more separate lines. So again this data bus is having separate lines. So I said the system bus is nothing but it is a group of lines. This group of lines is divided into data bus, address bus and control bus. So again this data bus is having some separate lines. So those lines will be of size 8, 13, 64, 128 or it may be so on. So the number of lines here in the data bus, the number of lines referred as a width of a data bus. Width of data bus. So here each line carries only one bit. So you have to remember that suppose the data bus is consisting of 8 lines. Suppose it is an 8-bit. Means 8 lines will be there in data bus. So each line carries 1 bit. Each line carries 1 bit up to 8 bits. Okay. So the number of lines referred to as a width of a data bus. So the width of data bus here is 8-bit. Means 1 byte. The width of data bus is 1 byte. Sorry, 2 bytes. So 1 byte is equal to 4 bits. So 2 bytes. Okay. So this is about the data bus. Now let us see what is address bus. Let me explain about address bus. So data bus is used to carry the data. Then what about the address bus? What is the use of the address bus? So address bus is nothing but it is having the collection of wires just like data bus. Those wires used to identify particular location in memory. So it is used to identify particular location in main memory. This is called address bus. So that's why in the previous diagram I seen that the address bus is a unidirectional. Only one direction will be there because that direction indicates it identify a particular location in memory. So it pointing towards to the memory means it identifying a particular location in memory by the CPU. So it is used to identify the source or destination of a data. The main use of address bus is used to identify the source or destination of data. Okay. So here example, the CPU needs to read an instruction or data from a given location in memory. Just like the CPU wants to read a data from memory. So if it wants to read a data from memory, first it has to know where the data is present. So that will tell by this address bus. The address bus holds the address of the data, that data presents in the memory. So the CPU needs to read an instruction or a data from a given location in memory. And coming to the width of the bus, how can you say the bus width? The bus width of address bus determines maximum memory capacity of a system. Maximum memory capacity of a system. What it means? So the bus width of address bus, whereas data bus width is determined by the number of lines it referred carrying. Okay, so suppose 8 lines are carrying, each line carries 1 bit. So if 8 lines means the bus width is 8 bit. So how what is the address bus width will be determined? It is determined by the maximum memory capacity of a system. So whatever the processor we are using, so that processor capacity, so the memory capacity is depends upon this address bus, determines the address bus. Let me explain with example. 8080 is a microprocessor has, suppose it has a 16-bit address bus. Means the address bus consisting of 16-bit lines, but it give 16-bit address bus giving 64 kilo address space. So even though it is a 16-bit address bus, it giving 64 kilo address space. So that is about the address bus. Now coming to the next, that is the control bus. So what is the use of control bus? Control bus is nothing but it regulates. I already said it always monitors all the address and data bus. So it regulates the activity on bus. What it means? What it regulates the activity on the bus means it is saying when to read the data and when to put the data on data bus and when to read the address on address of the memory location. So based on the address of the memory location, at what time the data has to be put on the data bus. So like that, it always regulates the activity on the bus. So it always controls and timing information. It always control and timing information. Means it holds all the timing information related to the buses. And it carries a signals that report the status of various devices. The control bus holds or it carries signals that report, that each signal is report the status of various devices, means whether the device is ready or not, or is the device is sending any data, like that. So it carries signals that report the status of various devices by this control bus. So there are different control signals will be there in the control bus. The control bus holds different control signals like memory read, memory write, IO read, IO write. So like that, these are the different typical control signals held by this control bus. So what this memory read means? So memory read nothing but it causes data from address location to be placed on the data bus. So we have to get the address location, a data from address location to be placed on data bus. Address should be the data from address location, right? Data from address location to be placed on data bus. So you just place the data on data bus with the help of memory read. Whereas memory write, the work of memory write signal is it causes data on the bus to written into address location. So means whatever the data that sends by the CPU, that data should be placed on the address location. Data should place on address location. So from a particular address location means from memory, that data is placed on the data bus so that the processor can read the data. Whereas memory write means whatever the CPU is executed, that should be placed written onto the memory. So that's why the data should placed on the address location of a memory. In the same way, IO read means data from address IO ports to be placed on the bus, whereas IO write is data on the bus to be output to the address of IO ports. So just memory read, memory write, IO read, IO write, or the different signals, you call it as a control signals, means it indicates the control bus. So what action you have to be do is you have to do a memory read, means the bus has to read the memory read, or it has to do the memory write operation, or IO read operation, or IO write operation, like that. Okay. So let me explain with some traditional bus architecture. A traditional bus. So here let me take this, a processor is there. A processor is connected with some local bus with a cache. Cache is a memory. It is a memory unit, a small memory unit that is present in the processor. Okay, so whatever the data the processor want to be executed, that or want to send to the other devices, that data will be stored in the cache. Cache is the fastest storage device after register. So this is a local bus connecting between the processor and cache by using the local bus. And here some local IO controller is there, input output controller. Okay, now coming to the main memory. This is the main memory, and this main memory and the cache are connected by using the system bus. Here this is the system bus, and after that with the system bus is connected with some expansion bus interface. Okay, so here an expansion bus slot will be there. So not only the system bus, you can also connect an extra buses to your device, your system, whenever it requires. If you need, you can connect some expansion slots. So here a network unit will be connected, or some modem is connected, or some serial, some input output devices are connected. Now let us see what is this a traditional bus. So here the one thing you are whatever the devices that are, these are the input output devices or the memory devices, is not directly connected to the processor. Okay, so whatever the processor is doing, that first sends to the cache. So the cache is connected to the system bus. Only the memory, this is cache is also a memory. Okay, so whatever the action that has to perform by the processor, or the processor sends the data that it stored in the cache, and this cache will be connected to the system bus. So the system bus is consisting of data lines, control lines, address lines. So in the same way, for this local bus is also, it is having data, control and address line. So whatever the bus, expansion bus interface is also having expansion bus, not bus interface. Expansion bus is also having all these three lines. So bus means it contains set of lines. So here the main memory is connected to the system bus and the cache. So the system bus is connected to the some expansion bus interface, so that some, with the help of expansion bus, you connect to some other devices also. So these all will be interacted with the system bus. The system bus will send the data to main memory. From main memory to processor, first it has to interact with the cache. The cache will send the data to the processor. So like that. So these are the different buses. So within the processor, so this is completely a CPU. You call it as a CPU. So within the processor, a local bus will be there. After that, a system bus will be there. After that, some expansion buses will be there. So this is about the bus architecture. Thank you.